my name is Kyle Bentley. I'm an application engineer with PROLIM PLM. In this lunch bite, we're going to be looking at the NX CMM application. In particular, we're going to be looking at how to use the NX CMM application to generate inspection programs. So for the agenda for using NX CMM for inspection, we're going to look at what is NX CMM if you're not familiar with it, and then the two processes for creating the inspection programs. So what is NX CMM if you're not familiar with it? CMM stands for Coordinate Measuring Machine. So inside of NX, we can generate inspection programs to run on our coordinate measuring machines. This is very similar to NX CAM. So we generate toolpaths inside of NX CAM or computer-aided manufacturing and then post those out to be ran on our CNC machines. So NX CMM is a separate environment inside of NX that we use to create inspection programs directly on the 3D CAD model. We can then use these tools to automate inspection programs, reduce our inspection programming time by 80%. Once we have our inspection programs generated, we can then post-process those and then run those on our CMM machine. So for the first process, we're going to look at how to set up an inspection template. Once we have our inspection template set up, we're going to look at how to create those inspection paths with PMI authored on the model. So what is PMI if we're not familiar with that? PMI stands for Product Manufacturing Information. You can see a couple screenshots here on the left. You can see the 3D annotations and dimensions on the model itself. You might have heard this referred to as model base definition. So how does the link to PMI work? Those dimensions have associated faces and edges that the paths will be associated to and be created on. So to create those features and inspection paths based on the associated objects. After we have the PMI and the inspection paths authored, we'll go ahead and create the alignment feature and then locate the part coordinate system. After we have the inspection paths and the alignment specified, we can then alter those inspection paths with the collision avoidance. After we have those inspection paths created and we've used the collision avoidance to optimize those paths, we can then use the machine simulation to validate to make sure our program does not have any collisions. Once we have verified it, we can then post-process it and then run it on our CMM machine. So let's go ahead here and look at a quick demonstration of a part with PMI already authored. So here I'm going to go ahead and pull up a part with the PMI already authored on the model. So here you can see that the dimensions are in 3D space. So what's important with the PMI is the associated objects. Notice when you select one, you're going to see the different features and the objects turn green on which objects are associated to that particular PMI feature. So notice I'm on datum feature A here. So when we go ahead and edit this dimension, you're going to notice that the three associated objects are those faces. So my inspection paths are going to be placed on those faces there. As we toggle down through those, you can see the associated objects for the other PMI as well. So let's go ahead here and look at a quick example of how to create inspection paths with the PMI already authored on the model. So let's go ahead and start our inspection program. So notice here we have a couple different start templates, and you might not have all of these in the list, so we need to go ahead and set up an inspection program. So we need to use the general template. So notice it imports my part into the inspection environment, and you can see that at the top of your screen. On the left here, you're also going to see that it also uses the inspection navigator. So similar to NX CAM, we also have three different views. We have the program order view, the machine view, and the method view. The two that you'll spend the most time in is the program order view and the machine view. So we don't have a machine or a CMM that we can validate our program, so we need to go ahead and import that in. So we can quickly do that by double-clicking on the generic machine on the machine view tab where we configure our machine. So I'm going to go ahead and import one from the NX library here. After I've selected which CMM I want, I'm going to go ahead and place it. And then after that machine has been placed, I need to go ahead and insert the probes that I'm going to use for my inspection program. Or if I already know the different probes and the machine that I'm going to be using, maybe I need to go ahead and save this as a template because I'm using it more often, and you won't have to change it. You can always use that template. And that's always in the file new. So notice I have my own templates that I use for production as well. So I have different probes and different machines that I consistently use. So those are my start templates. So I don't have to import a machine and probes every single time. So now I need to go ahead and import those probes. Okay, so in my production environment, I have two probes in my tool change rack, so I need to insert my other probe. Okay, with the probes inserted here, you're going to notice that I imported two. Now I can expand that, and I have different pockets here. I can see those, so I can configure this and move them around if need be. I can also import more. So we need to go ahead and specify the tool numbers for this. So notice they're both 1, so I'm going to go ahead and specify the next one in sequence. The last thing we need to do is go ahead and specify the CMM head that we're going to be using. So I'll go ahead and specify that or retrieve it from the library. Okay, with our machine configured, now we're ready to start our inspection program. So notice we can't see the PMI at the assembly level. We're also going to go ahead and create a filter. Now you don't have to do this. This is just for a visual. So then we can go ahead and apply that filter to all the views. And then we'll be able to see the PMI at the assembly level. So now we need to go ahead and position the part. Maybe we also have a fixture in production that we use consistently as well. So I'm going to go ahead and add a fixture in here. Okay, with the fixture placed, I need to go ahead and position my part as it is in the production environment. Okay, with the fixture and the part positioned, now we're ready to go ahead and start our inspection program. So note that we have the PMI already on the model. So let's go ahead and take advantage of that. So we have our probe and our CMM head and our machine imported. We're ready to start the inspection program. So with just a click of a button, we can go ahead and create the inspection paths, features, and tolerances with just a couple clicks here. So with the link to PMI, all you have to do is select the component. It'll recognize the PMI in the model. We can select the tool, or it will optimize the size of the probe based on the features that it's inspecting, so it will switch automatically, or you can specify one. For this example, I'm going to go ahead and specify my TP20. After the PMI has already ran, it'll tell you that it has been successfully linked. Now, you might have some that aren't successfully linked, and those could be construction objects such as center marks and center lines. With the paths created, I'll go ahead and generate the program, and then we can expand the inspection paths, and we can see those here as we scroll down. Okay, with the inspection paths created, we can then go ahead and simulate our inspection program. So in order to simulate the program, we need to make sure the top level is selected, and then select our machine simulation. Before we run the machine simulation, we need to specify different collision pairs to make sure that there isn't any collisions. So I'm going to go ahead and go into the machine settings here, and then specify the different pairs. Now inside of NX, you can specify the different pairs between maybe a part and the different probes, maybe between the table and the probe, or the part and the head. So I'll go ahead and specify a couple of those here. Notice as I specify the tool, it'll go ahead and specify the different objects for me here. As I specify the part, it automatically selects that as well. So then maybe I do one for the part and then the head as well here. And then maybe we do one for the table. Okay, and then we'll also do one for the tool and the table. With our collision specified, we can then go ahead and verify our program that we have. Okay, so as we run through the program, if there's any collisions in our program, you're going to see a collision message come up. If there is a collision, you'll notice that it will highlight red and yellow between the collision. You can either specify to hit continue, and it'll go to the next collision and then stop and give you the message again, or you can hit continue until reset, and it will just flash whenever there are some collisions. So notice there were a few in there on that path, so maybe we need to go ahead and fix it. So there's a few on the rotations and transitions. So let's go ahead and fix those collisions there. Notice that it went through the part on that one. Notice there's one on the table. So it's just trying to find the quickest way between those. So let's go ahead and fix these. So we need to go ahead and select the top level program, run the collision avoidance, and then we need to specify a safe plane. So notice in here, move to safe plane for probe rotations, and then we can insert transition points between paths. You can do it within the path as well. It's going to move measurement points. It'll delete measurement points if it can't get to those. We can also change the probe tip to avoid collisions, and actually change the probe as well if we have more than one. So let's go ahead and specify the safe plane. So make sure you have the entire assembly filter so you can select every object in your assembly. And then I'll go ahead and specify a distance above the part as 150 millimeters. And then it will optimize those paths. So it will insert transition points. Some of those paths don't have any collisions, and it'll give you a report and tell you that. In the last path, plane 3, 2 measurement points were moved, and then it also inserted some transition points as well. Okay, now that we have ran the collision avoidance, let's go ahead and rerun the machine simulation here just to verify that our program is correct. Okay, as you can see, the first path is better. It also goes to that safe plane to make our rotations so we don't get any collisions. So as you can see before, the CMM head went directly through the part. Now it's going to the safe plane to make those probe rotations. And now we don't have any collisions. So now that we have our inspection program created, the last thing we need to do is specify the part alignment or the part coordinate system. So introduced inside of NX 10, we have the alignment assistant. This can help us specify the alignment. You could also specify the alignment manual. Maybe you can also specify the alignment with a teach point. You can tell the operator to take a teach point and then start the program. You can also do that as well. For this example, I'm going to go ahead and use the alignment assistant. So with the alignment assistant, there's three different types. I'm going to go ahead and use the plain cylinder. So I'm going to go ahead and specify my PCS here. And then I'm going to specify the tertiary and secondary objects here as well. Okay, now that I have the PCS generated, we can see the coordinate system that we have. So it shows our part coordinate system. So that is where our points will come from to run our CMM machine with the post processor. Okay, now that we have those inspection paths created, we need to go ahead and rerun the collision avoidance on the part alignment paths. So what I'll do is I'll select the part alignment paths and then rerun the collision avoidance. Notice it also still has the safe plane specified, so I'll just go ahead and press OK. And then it will go ahead and give us a report on those inspection paths. Note that there's only 3 of those, so there's only 3 paths in here. Okay, so let's go ahead and run the machine simulation on the whole inspection program. So now the machine's going through its alignment. Maybe that's where my fixture is, so I'm going to go ahead and find the alignment of that part by my first, secondary, and tertiary objects here that it's going through. Okay, and then it's going through the inspection program. So that is how we can quickly create our inspection programs with PMI authored. As you can see, with just a click of a button and just a few clicks, we can get our inspection program in just a few minutes. So now that we're ready to post this out, all we have to do is simply right-click on it and then go to Post Process on the top level. And then we have our different post processors. So we have post processors developed for the mCosmos, PC DEMUS, and we can also post to the standard DEMUS 5.2. After you have it selected, you can then specify where you want to put that post processor. As you press OK, it'll go ahead and pull up the post that you will be using. Okay, so let's go ahead here and look at the second process that we can use for creating inspection programs. So the second process is if you get a model that doesn't have PMI. So if you're not using PMI today, you'll have to use this process. Or you might also receive a part such as a step file or a neutral format that doesn't have any associated PMI on the model itself. So the second process, you have to set up the inspection template or use a template that you already have set up, which we'll look at here. Create the inspection paths without PMI. So there's a couple different ways to do that. You can either author the PMI on the 3D model or create inspection features and tolerances inside of the NX CMM environment itself. And then it's the same from there. We'll create the alignment features such as the PCS as we did before with the alignment assistant, and then alter those inspection paths to make sure there's no collisions, validate it with the machine simulation, and then post it out so then we can run it on our CMM machine. So let's go ahead here and look at a quick demonstration with the part that doesn't have PMI. Okay, so I'll go ahead here and open up another part. For this example, I'm going to go ahead and show you how to create the inspection features inside of the NX CMM environment. You could also create the PMI dimensions on the model to be used with the NX CMM environment using the link to PMI instead if you wanted to do it that way. So let's go ahead here and start our inspection template. Instead of using the general template, I have a template already saved. The Sheffield template that I have been using, I'll go ahead and open that up. Notice as I select that, it has the probes that I have for production. So it has one more in there that is already inserted. So every time I use this template, this is what I'm going to get. So I get my machine simulation and the different probes I have. I could always insert more probes. I could always change the CMM head if I wanted to. So you could always configure it on the machine view. So I'm going to go back to the program order view. So in this template, also notice we have a part alignment. So in here, this one has one so to take the teach point manually. So it's telling the operator, or the CMM command is what they're using here, to specify the different measurement modes such as manual, and then you can enter the different statements as well, or the message to display at the CMM machine. So in this message, it's telling the operator to take a teach point based on the DEMAS standard here. So I'm going to go ahead and specify the teach point on my part, and then generate that part alignment. Okay, as you can see, it specifies the path for me, and then the alignment. Okay, with the alignment specified, so I did that first. Again, the order does not matter in the way you do it. You could either specify the alignment after you do your inspection paths or before. Okay, so we have our alignment. Now let's go ahead and look at how we create inspection paths without PMI. So if we go over to the inspection path command, you're going to notice that it says for a feature name. Now the only feature created in here is the teach point. Notice it says select features. So if you try to select that hole, it's going to tell you that that is not an inspection feature. So you have to specify the different features before you could create the inspection paths. And the way you do that is with these features here. So we have some different ones we can use. You have different ones for curves, for scanning curves, if you use the Revo head. And then you also have the different faces as well. So we could do a plain cylinder. You could use those for holes. We also have contoured surface as well. So let's go ahead here and do a couple of these. So I'm going to go ahead and run the cylinder. With the cylinder selected, I'm going to go ahead and select the holes. Notice that it's specifying the feature name and it's going to build the features. If you want to better help yourself remember those features, you can name those here, and we'll see that in just a second. For now, I'm just going to go ahead and press apply on all these. Okay, so I have my features created. Notice that it counts the next one in sequence. So if I wanted to have a naming convention so I remember which one is which, you could specify it as hole 1, hole 2, hole 3, hole 4, and boss, for example. That way, when you create the inspection paths on each of these, you know which one is which, so you're not trying to guess at it. So we'll see that here in just a second as well. So I'm going to go ahead and specify a couple different planes. Okay, so I have some planes specified and the different cylinders as well. So I'm going to go ahead and generate those. Okay, with those generated, I'm going to go ahead and create an inspection path. Now notice it says select the feature. So we can select it from the drop down or select it if it's already created as a feature. So that is another thing you can do with that, is you can select it in the graphics window as long as you've already created it as a feature. Notice here, if you want to select it from the drop down list under feature name, your features could get very long depending on the complexity of your part. So for example, if I don't know which hole it is, I might have to select it to see if I've created an inspection feature or select it from the list based on my naming scheme. So I'm going to go ahead and select it. It has the vector direction based on how I created that feature, and you could change it. So it's going to inspect down. And then it has the method that it's going to use, which we'll see here in just a second. So it's using the cylinder method. So I'll go ahead and generate that path. Notice the number of cross sections and points per cross section. Okay, so I can change that as well. So I could specify the number of cross sections to be 4 if I wanted to, or I could say, for best practice, I could leave it as 2 here. So as I press OK, it generates that inspection path. So I can then animate that inspection path to see it. Okay, so that's how we quickly generate an inspection path. Now, NX uses the method views for best practice on different objects, such as the cylinder here. So under method view, I have an inspection path already created. It has the different cylinders under the inspection cylinder and the path as well. So under here, you could change the different number of cross sections for each path. So notice it was using 2 and 4. So it's going to create every path with 2 and 4. If you want it to be different, you change it here. So this is your best practice area or your method view and how you want it to be inspected. So let's go ahead and create an inspection path on the, let's go ahead and create it on another cylinder here. So I'm going to go ahead and use the inspection path. So notice I did cylinder 1. Let's go ahead and do cylinder 2. I'm going to go ahead and add the inspection path. Notice that it's using the default or the methods here. I can then change it if I want to. I can say 4. Okay, so there's my inspection path. Now if I want to change that inspection path, I can come down into the inspection paths. You can then double click into it, and then you can also edit that inspection path here. So you can also edit it back if you don't want 4. So I can change it back to 2. Okay, from here, let's go ahead and look at how to generate multiple different inspection features. So a multi-path. So it quickly creates multiple different paths in just a couple clicks here. So if you're doing the way to program without PMI and you have to select the different features, you don't want to keep using the single inspection path on each individual feature. The way to quickly generate multi-paths is use the multiple feature paths. So we'll go ahead and select that and it'll give you a list. Now notice you can select them, you still can do that, but they have to be inspection features. Or you could have them as a naming scheme so it makes it a little bit easier to see. So I'll go ahead and select them in a list and then add them to create the paths here. So notice you can also specify the tool to be used, or you can leave it on auto. So I'll go ahead and leave it on auto and then press OK. So notice it quickly created those inspection paths on those planes there. And it also has a best practice or a method for those as well. So I could have changed it if I wanted it to be more points. Again, we could always change this accordingly. So let's say I want to change the number of points in the U and V direction. Now notice I have some collisions here. Okay, so I have my inspection paths based on my different features that I have created. Again, we can create more inspection paths and more features as needed here. We have our part alignment, so I'm going to go ahead and generate my program. Okay, from here, let's go ahead and run the machine simulation. Okay, notice that they have identical tool numbers here for the TP20 and the SP25. So we can change those as needed. We can go into the machine view and change those here. And then I'll do the next one in sequence. And then we can go ahead and regenerate our paths here. Okay, after we get that generated, let's go ahead and run the machine simulation. Now, before we run it, let's go ahead and check our settings for our different pairs. Notice there's ones already specified in my template. It has one for a tool and a fixture. And then it also has one for the tool and the part. So it's already specified and I didn't even have to select it. So I'll go ahead and run the machine simulation now. Okay, so it takes the teach point and then it's going through those paths. Now we did have a collision on one of those paths here, as you can see. So let's go ahead and use the collision avoidance to fix that. So notice it's trying to do the side path here and we're having collisions in the table and the different the tool and the part as well. So let's fix it here. So let's go up to the machine simulation and I want to specify another pair. So I'm going to do another one in here. Let's say we do the CMM head and the table. Okay, so we do the CMM head here, and then let's say we do the machine, and then let's also do that with the tool as well. So let's say between the tool and then the table. Okay, now let's go ahead and run our collision avoidance. And then we're going to go ahead and specify a safe plane. Again, remember to check your assembly filter. So I'm going to go ahead and specify that 150 millimeters above the part. And then it'll go ahead and optimize those paths. Okay, with the collision avoidance ran, let's go ahead and simulate that. And then let's check on the different paths here. So let's go ahead and run through it, just to validate to see what we got before we post it out. Notice it went around the boss, and it went in the different sensor chains. So it did not go in the angle it did before. So we don't have any collisions. We are now ready to post out our inspection program. Now, when you bring the inspection program back in, you'll also have to specify the different tolerances. Now, although we created our inspection program, it does not automatically create the different tolerances. The way you do that is with the tolerance values up here. So you have your different dimensions, your different characteristics, such as true position and flatness. So we could do the true position. For example, select the PMI object. What that means is select the feature that you want to specify as your tolerance value here. So I can specify the cylinder and then the zone shape as cylindrical. So then you could specify the different material modifier and then the different datum references as well. Now notice I don't have any different datum references, so we need to go ahead and specify those. So let's do that first here. So let's go ahead and create my different datums. So we can go ahead and specify the datum. And let's say we use plane 1 as datum A. And then we'll hit apply on that. And then we'll go ahead and specify the next plane as B. And then go ahead and press OK. Now we can go ahead and use the true position, for example, here. So we'll go ahead and specify the cylinder 1, specify the zone shape, and then for the material modifier, we can say maximum material condition, and then the primary datum reference we can say is A. And then you can type in your tolerance value. Let's say I do, let's do a 0.5 millimeter here. And then we'll go ahead and press OK. Now notice the tolerances need to be generated, and then we can post that and pull in our physical data to be applied to the actual physical model. So we can use the graphical reports and the measured data so we can see which deviations we have, if it needs any rework or anything like that. So that is how we quickly generate programs inside of NX without PMI on the model here. So that's all I have for inspection programming and how you generate your programs inside of NX CMM. If you have any questions or concerns or any further lunch bite suggestions for us, email our engineering support team at technical.support@prolim.com. Thanks, and have a great day.